So we were doing types of chemical reactions, right? So once again briefly we discuss about the types of chemical reactions and then we go to the next topic. Okay. So here when you come to the types of chemical reactions, we have 4 types of chemical reactions. I explained you. The first one is combination, second one is decomposition, and third one is a displacement, and fourth one is a double displacement. Okay. Now in that combination means what? A reaction in which 2 or more reactants combine to form a single product. Reactants may be 2 or more, but product is only 1, then that is called as a chemical combination. And so example, I give many examples, but okay, let's see here. Magnesium, when react with oxygen, it forms magnesium oxide. So here these 2 are the reactants, reactants are 2, but product is 1. This I gave an example for the combination reaction. Next come to the decomposition. Decomposition reaction, I said that a reaction which the reactant is only 1, but products may be 2 or more. Okay. So we can get 2 or more products from a single reactant. So that is called as a decomposition. Yes. And in the decomposition, I said that there are 3 types of decompositions are there. The first one is the thermal decomposition, second one is called electrolysis, and third one is called photolysis. Okay. And thermal decomposition on heating, so a substance, one reactant will decompose into 2 or more, okay, products. On electrolysis, second one is electrolysis, means on passing electricity, the one substance decomposes into 2 or more. And third one is photolysis, when you pass the light, in presence of light, one substance decomposes, means splits into 2 or more products. So this is called a decomposition. So decomposition means what? One reactant splits into 2 or more products. Like thermal decomposition, I give CaCO3 calcium carbonate. On heating, it gives calcium oxide plus carbon dioxide. For electrolysis, I give 2H2O, gives rise to 2H2 plus O2. And for photolysis, I give silver chloride, AgCl2. In presence of sunlight, it decomposes into Ag plus Cl2 minus. So these 3, in these 3, the first one is the first one is thermal decomposition, and the second one is electrolysis, okay, and the third one is photolysis, means in presence of light. Okay. So this we discussed. These 3 types of reactions we discussed in chemical combination. Now displacement, what I said, here more reactive element displaces less reactive element from its compound or from its solution and forms a new compound, is called a displacement. Okay. For that I gave an example like iron, Fe, when you add in the copper sulfate solution, blue colored solution, then this iron displaces copper. So to form FeSO4, here CuSO4 is there, copper sulfate, but now it becomes ferrous sulfate plus copper. Okay. So this element is displacing. And if you add the copper in ferrous sulfate, it do not take place reaction. This also explained you. Why it do not take place? Because okay, copper is less reactive than the iron. So copper cannot displace the iron, but iron can displace the copper. Okay. So these three types of reactions we discussed, I think. Did we discuss about the double displacement reaction? No. So fourth one today. Now let us discuss about the fourth reaction, that is double displacement reaction. So see now, write the definition. Double displacement reaction. Okay. The definition of double displacement reaction is a reaction in which two compounds or two reactants exchange their ions to form two new products. Okay, is called chemical double displacement reaction. So see the definition, write this definition. A reaction in which two reactants exchange their ions to form two new products is called chemical double displacement reaction. Okay, so write this one and then I will explain one example so that you can understand very easily. Right. Now see here, for example, I will take sodium sulfate solution. Sodium sulfate. Okay. To this sodium sulfate solution, I will add barium chloride solution. Barium chloride. When I add these both solutions together, they will get new product. Okay. That new product is sodium chloride plus barium sulfate. Okay, so here I am taking the sodium sulfate and barium chloride, but I am getting the sodium chloride and barium sulfate. So here sodium sulfate becoming sodium chloride, barium chloride becoming barium sulfate. So what's happening here? Here they are exchanging. Okay, so the sodium is giving this sulfate. Okay, giving this sulfate to barium, and it is taking chloride from barium sulfate. Is this clear to you? So here sodium sulfate, sodium is giving its sulfate to barium and it's taking its chloride. So it's forming, okay, sodium chloride and barium sulfate. So a reaction in which two reactants. So these are the two reactants. This is the first reactant and this is the second reactant. So we have the two reactants. Okay. Exchange their ions. So means what? It is giving its sulfate to that and it is taking the chloride from it. Exchanging. Exchanging, you know, exchanging. So exchange their ions to form two new products. Now we are getting two new products. Here sodium sulfate is becoming sodium chloride, barium chloride is becoming barium sulfate. So two new products we are getting. So this phenomena, this type of chemical reaction is called chemical double displacement reaction. Is this clear to you? And in terms of chemical equation, if you want to write, okay, in terms of chemical equation, if you want to write, then the chemical equation can be written like this. Okay, sodium sulfate formula is Na2SO4. Okay, barium chloride formula is BaCl2. Okay, now they are exchanging their ions, so that what we get is sodium chloride, we get the sodium chloride is 2NaCl plus barium sulfate, that is BaSO4. So this is a chemical equation. Okay, so sulfate is going there and chloride is coming here. So exchanging their ions, this reaction is called a chemical double displacement reaction. Is this clear? Chalo, note down this reaction. Examples. Done. Chalo. Now with this 4 types of reactions are done. Now we are going to the next one more type of reaction, that is called oxidation and reduction reactions. What are the next one? Oxidation and reduction. Oxidation and reduction. Here both are right like this so that you can understand very easily. Okay. Oxidation and reduction. So this oxidation reduction have many definitions, but here I am going to discuss 3 definitions. Okay. So 3 definitions I am going to discuss here. So listen carefully now. So here oxidation, the first definition what can write is a reaction in which addition of oxygen takes place. So that is called oxidation. So in simple I will write addition of oxygen. Okay. So addition of oxygen is called oxidation. Now reduction is exactly opposite to the oxidation. So what can we write now? That's all. So here the definition it comes, a reaction in which removal of hydrogen, removal of oxygen, no? Yeah, sorry. So removal of oxygen. Okay. Removal of oxygen from a given compound is called reduction. Addition of oxygen to a given compound is called oxidation. Removal of oxygen from a given compound is called reduction. One more definition. Now one more definition here. Here addition of oxygen. Now we can write other definition is what? Removal of hydrogen. Removal of hydrogen is also called as oxidation. Now for this opposite is reduction. So what can you write? Chal. Addition of hydrogen. Addition of hydrogen is called a reduction. One more definition is also there. In terms of electrons, loss of electrons, electron or electrons, one or more. So I am writing like this, electron or electrons. Loss of electrons from any reaction, from any compound, if any element is losing the electrons, then that is called oxidation. Then what you write in the reduction? That's all. So gain of electron or electrons, okay, is called reduction. So with these are very 3 important definitions. So oxidation is what? Addition of oxygen to a given compound, or removal of hydrogen from a given compound, or loss of electrons, okay, is called oxidation. Exactly opposite to that one, removal of oxygen from a given compound, or addition of hydrogen to a given compound, or gain of electrons, okay, is called reduction. Is this clear to you? Chalo, note down this one. Completed? Chalo. Now let's go to some examples. So when you come to the oxidation example, like in the combination reaction you have seen that carbon plus oxygen gives rise to carbon dioxide. Yes or no? Carbon burn in oxygen to form a carbon dioxide. This is oxidation reaction. Why? The carbon, okay, we are adding the oxygen to the carbon. Actually carbon is individual, but what we are doing, we are adding the oxygen to the carbon. So we are getting the carbon dioxide. So here only carbon is there, but here carbon dioxide is there. The meaning is what? Oxygen is added to the carbon. Yes or no? So that's all. This is called as the oxidation reaction. Now reduction is what? Removal of oxygen. Okay, removal of oxygen. For example, if you see, let me take the zinc oxide reduction. Okay, I am taking for example zinc oxide. This is the zinc oxide. ZnO is called zinc oxide. If this zinc oxide, if I heat, okay, with the carbon, okay, if I heat with carbon, then what happens? This carbon removes the oxygen from the zinc, so to form zinc, okay, and we get carbon monoxide is a gas. Carbon monoxide is gas, it escapes. Okay, so I am taking the zinc oxide. Whether I am okay, I am heating with the carbon. Zinc oxide I am heating with the carbon. So here, what is my okay? This one zinc oxide. So in this oxygen is there, but in this what is my product here? Zinc. Is there any oxygen in the zinc here? No. From zinc oxide we removed the oxygen only, we made zinc individual. So this reaction is called the reduction reaction. Is this clear to you? Okay. So note down this one. Yeah. Then it. Okay. So now here you see, now I am going to discuss about the redox reaction. What is the next one? Redox. Can you say what's the meaning of redox? Redox reaction. So redox reaction is what? Very simple. You split this redox into two parts. Okay, you split this redox into two parts. What are those two parts? One is red, second one is ox. Okay, what is the two part of the two parts? One is red and the second one is ox. So red for reduction, ox for oxidation. So the reaction in which both the oxidation and reduction taking place simultaneously. Clear? A reaction in which both oxidation and reduction reactions are taking simultaneously, means at a time, then that is called the redox reaction. See here, for example, what we do, we take the copper. Okay, generally we take the copper. Okay, so copper. Copper actually reddish brown in color, you know that, yes or no? Copper is in reddish brown in color. Now what I do, I heat this okay, copper in presence of oxygen. I burn the copper in presence of oxygen. Okay, when I heat the presence of oxygen, then what happens? It forms copper oxide. What it forms? Copper oxide. So this is black in color. What is the color of this one? Black in color. Okay. So now copper is combining with oxygen to form a copper oxide. Now this copper oxide black in color. Now if I want to write that this as a chemical equation, so how can I write here? 2Cu, that is copper, and burning in oxygen with O2, so I am getting 2CuO. Whereas this is black in color. Okay, sorry, this is copper, so copper in which color? Reddish brown in color. Okay, and this is black in color. Okay, so I am getting copper oxide, right? Now what I do is, now to this copper oxide, okay, when it is red hot, now forget about this one. Now this one you forget, this we got it. Okay, so red copper oxide. Now what I do, through the red hot copper oxide, I pass a hydrogen gas. What I pass? Hydrogen gas. When I pass a hydrogen gas, then what happens? This hydrogen absorbs this oxygen. Okay, it absorbs this oxygen, means what? It reacts with oxygen and forming here copper plus water, H2. Okay, so oxygen, hydrogen is absorbing this oxygen, means taking this oxygen and forming H2. Okay, So from the copper oxide, oxygen is going there. So what is left here? Copper is left. So oxygen is going with the hydrogen. So what is left here? Copper oxide. Is this clear to you? Now you see here. Now you take only this part we take. This part of reaction we take here. This part of reaction we take. Okay. Now you compare here this and this. Which two? These two you compare. Okay. So this is the reactant, otherwise I will remove this all. Oh. Okay. Now you compare these both. Now which reaction is taken place here? You see here copper oxide is there, copper is there. Now which type of reaction took place here? Oxidation or reduction? Reduction, because here copper oxide is there, here copper is there, means oxygen is removed. So this is what reduction. Reduction. Okay. Now here you see. Okay. Now here you see. Here only hydrogen is there, and here H2O is there. Okay. Only hydrogen, but here oxygen is added to hydrogen. So only hydrogen, but here hydrogen with oxygen. So what type of reaction took place here? What reaction? Oxidation reaction, because here only hydrogen is there, but here oxygen got added here, so it became water. So this is what oxidation. Okay. So this total in one reaction only. To copper oxide we are added the hydrogen, so that we are getting copper and water. So in this is the total actual reaction. This total reaction is this one. So in this total reaction, one reduction reaction is taking place, one oxidation taking place. So both the reactions are taking place in one single reaction. Is this clear to you? Such type of reaction is called redox reaction. Is this clear? Chalo, copy. Good boy. Chalo, now the last and final topic of this chapter is corrosion. Okay, what is the last and final topic? I think corrosion we discussed somewhere in the metals and non-metals or some topic, but okay, once again. So corrosion, what is the corrosion? Iron particles become rusted, yes or no? So this is called as a corrosion. See here, already we discussed I think in the metals and non-metals, but once again. So here, metals are more reactive elements and they are electropositive in nature. Okay, metals are electropositive in nature. Due to their high electropositivity, they are high reactive in nature. Okay, so most of the metals, they do not available in the nature in the form of metals, means as it is they do not available due to their nature. Okay, due to their nature. Okay, their nature is what? They are electropositive and they are highly reactive. So that's what in the nature. For example, if you want to take iron from the nature, means from the underground, nowhere you will get the iron as it is. You know, I think you might have studied in the somewhere in the social or the science. They will be available in the form of ores and minerals. What are the ores and minerals? In which metals are mixed with some other metals and available to us. So they are called ores and minerals. Okay. Similarly, if you take the sodium, potassium, magnesium, calcium, aluminium, these all are metals, but then nowhere these metals are available in the nature as it is. Okay. So how they are available? They are available in the form of minerals and ores. Means what? They are combining with some other elements and they are forming that minerals and ores. So those form we get. Now what we are doing, these minerals and ores we are taking and we are removing the impurities and we are separating the other elements and we are taking the pure element from them. Is this clear to you? So that we can get the metal. So, but when you take the metal, but it has its own nature, yes or no? It has its own nature. Okay, so for example, you are there, okay, Akanksh is there. Akanksh is a very jovial person, very kind-hearted person, and he is a very friendly person, and he want to, okay, have a friend, so many friends with him, okay. So such person is there. Imagine, just okay, example I am telling, okay. But suddenly, for example, your parents taken you and they shifted from, okay, Hyderabad to, sorry, wherever you are there, from your place to some new village, okay, some new city, some new village, somewhere you are shifted, all total family, okay, and you are there. And what is your nature? Your nature is very friendly nature, you are a kind nature, you are a nice person, okay. So then you join in another school there. Then what happens? Can you make other friends or not along with you? New friends? Yes. So that is your nature. Yes or no? So even you are separated from your old friends and going to the new place, you are making the friendship with a new one. Yes or no? So here metals also have the, okay, actually their nature is that they are already combined in the nature, they combine with other elements and they are already available in the nature in the form of minerals and ores. Means what? They are combined with the combined state we get. So they may mix with the oxygen, they may mix with the carbon, they mix something. Okay. But now these people, what they are doing, business people or what these people or human beings, what they are doing, they are taking that minerals and they are separating, okay, all these impurities and their friends like carbon, oxygen, whatever sulfates, whatever they are removing and they are making pure metal. Okay. But that pure metal has its nature to combine with other elements, yes or no? Now, if we take that pure metal we purchased and if we use that metal, okay, we keep somewhere. So what happens? Its nature is that to react with other elements, to make a friendship with other elements. So now it will make a friendship with oxygen in presence of moisture and it form a rust. Copper is there. Copper also can form like that. Okay, it can combine with the carbon dioxide and it form copper carbonate. That's also like a rust. Okay, corrosion. Silver is there. Silver reacts with the sulfur from the oxygen, okay, and forms a black coating on it. So that's called a silver oxide. So this reaction is called a corrosion. Is this clear to you now? So that is a corrosion. So corrosion means what? According here, metals react. Metals react, okay, with the elements present in the atmosphere. Present in the atmosphere and get corroded. Corroded means what? Like forms rust. So this phenomena is called corrosion. So when iron, okay, corroded, then that is called iron oxide. Okay, iron oxide, which is called as a rust. Okay. So similarly, copper also undergoes corrosion and it forms copper carbonate. Copper carbonate. Similarly, silver also get corroded with the silver or with the sulfur and it forms a silver sulfide. Okay, silver sulfide. So like this they corrode. But when they corrode with each other, then what happens? That metals get spoiled. What happens? That metals get spoiled, means damages. Its strength will lose, okay, it loses its mass. So they have so many bad effects on there, okay. So when iron, if you take one iron piece, which for example you think 1 kg iron piece you are getting and just you are kept on your terrace of your house. So due to rain, due to moisture, due to sunrise, okay, everything it is reacting and after 1 year if you see all get corroded and all right rust will form. If you clean it and measure, it may be only half kg or something, okay. So it lost some mass, yes or no? So like this happens. So that is called as a corrosion, okay. So corrosion is that. Now how can we prevent this corrosion? Okay, can we prevent the corrosion? Yes, we can prevent the corrosion. How can we prevent the corrosion? Prevention of corrosion. Okay, so there are so many methods out there. Okay, by oiling, by greasing, by painting, by galvanizing, by alloying. Okay, so these all are the methods to prevent the corrosion. So what are the methods here? By oiling, by greasing, by painting, by galvanizing, and by alloying. Is this clear to you? Alloying means what? Mixing of metals. Okay, mixing of metals. Like for example, that iron get rust. But when you, whatever the glass means tumblers you use, the stainless steel tumblers, stainless steel. Our tiffin boxes and the glass tumblers are made up of stainless steel. Yes or no? This stainless steel is also made up of iron only. Okay, but along with that, in that some chromium, some manganese, some zinc, some other element, other metals will be added, and that is called alloying. Alloying means what? A mixture of metals. Alloying means what? Mixture of metals. So that is called alloying. Clear? Yeah. Now the last and final topic, okay, that is called rancidity. That one I'll explain you. So with that chapter will be over. Rancidity. Rancidity is like a corrosion only, but oxidation process only. But it takes place on the food articles. Okay, where it takes place? Food articles. You know that when your mom cooks something, okay, rice, dal, curries, anything, whatever it may be. So she is cooking something and she kept outside, and for example, she forgot to, if anything is left night, she forgot to put in the refrigerator, and next day if you see, it will get spoiled and will get some smell. Yes or no? That is called rancidity. Okay, so generally food which are made by the oil, generally oily foods, what happens, if you put for a long time, then they react with the oxygen and they get spoiled, and one different type of smell will come from that. So the spoiling of food is called as a rancidity. Spoiling of food is called rancidity. Is this clear to you? So how can you prevent the rancidity? Very good. So by keeping in airtight containers. Okay. By refrigerator, by keeping in refrigerators. Okay. And more. And by using antioxidants. Antioxidants means what? Oxidant means what? Which react with oxygen. Antioxidant means what? Which do not allow to react with the oxygen. They are called antioxidant. Is this clear to you? Like for example, when you go to the chips, if you want to go to a shop and purchase a chips packet, okay. So when you see the chips packet, then the packet will be very big, okay. Something it will be very big packet, okay. So very big bulges like this, okay. Lot of like big packet will be there, okay. But when you open this chips packet, then you can find only few chips inside. Hardly 10 to 12 chips only we can find. Okay, remaining all inside some gas will be there. Yes or no? Do you know what is that gas? No, that gas is nitrogen. Which gas? Or sometimes helium gas also can be used. So nitrogen gas. Okay, that is not a oxygen, because oxygen can spoil the food. Oxygen can spoil the food. So, to not to react with the oxygen, what they do is they fill with the nitrogen gas. So, nitrogen acts like an antioxidant, means what? Which do not allow to react these chips react with the oxygen. So, it will prevent. So, they are called antioxidant. Is this clear to you? Chalo, that's all. So, with this we done this topic, and 1 minute, I think it's not clear. So, with this actually we completed this chapter. Okay. So, here few questions are given here. Once you see these questions, okay, fast we discuss. Which of the following gas can be used to store a precious sample of oil for a long time? Come on, say. Very good, nitrogen and helium. So, here which of the following is getting reduced in this reaction? Iron oxide reacting with carbon monoxide to give iron and carbon dioxide. Which is getting reduced? Reduction. Reduction means what? Removal of oxygen. From which oxygen is removed? From iron oxide. Okay. So, this is iron oxide becoming iron here. Okay. So, the meaning is what? Iron oxide is getting reduced. Clear? Now, fatty foods become rancid. This is which process? Oxidation, corrosion, reduction, hydrogenation. Oxidation. We store silver chloride in the dark colored bottles. Why? A white solid undergoes redox reaction to avoid the action of sunlight. None of the above. What is the right answer? Silver chloride. What happened? Silver chloride is photolysis. What is that? Here, silver chloride. Here, it is photolysis. Silver chloride is decomposing in presence of in presence of sunlight. So the answer is sunlight there. Okay, the answer is what here? In presence of sunlight, it will decomposes. Next, silver article turns black when kept in open for a few days due to the formation of what? Hydrogen sulfide, silver sulfide, silver sulfate, silver sulfide. Silver sulfide, that is Ag2S. Okay. And when carbon dioxide gas is passed through the lime water, what is formed here? Lime water means what? Calcium hydroxide. Lime water is what? Okay. This revision, this worksheet we do later. And what is the last chapter is left? I think so. Okay. With this chapter is done. And in the next 2 classes, I am going to discuss about the last chapter. What is the last chapter? Behavior of gases. In that, we are going to discuss only about the 3 laws. One is Boyle's law, Charles law, and Avogadro's law, and ideal gas equation. Okay? Yeah. So, in the next class, we discuss. Next class we discuss about the gas laws. Okay? Bye then. Take care.